In this lesson, we're going to be talking about multiplying and dividing real numbers. Make sure you have your Algebra 1 book out and open it to page number 56. Now, the first thing that the Saxon math book talks about is how when you multiply numbers, multiplying is just like adding. It's a way for us to show repeated addition of the same number again and again and again. So you see there that they show you we could add 2 3 times. 2 plus 2 plus 2. Now that's obviously 6. But wouldn't it be nice if we had notation that didn't require us to write out those 2's all those times? Imagine if we had a larger number of 2's, 2 added to itself 10 times or 20 times. Well, there is an easier way to show repeated addition, and it's just 2 times 3 equals 6. All it means is it's 2 plus 2 plus 2. I do the same thing. 3 times 2. 3 times 2 is just 3 2 times added to itself. 3 plus 3 equals 6. Okay, so that's all multiplication is, repeated addition of the same number. And when we start thinking about this repeated addition, we realize that there are some properties that real numbers have when we multiply them. Okay, so we're going to look at some properties of real numbers today when we multiply and divide real numbers. And this works for any real number. Remember, this includes numbers that are natural numbers, whole numbers, so 0 is included in these. We can include integers, so negative numbers as well. And then all of the rational numbers as well. So anything that is a fractional number or decimal number works with this too. Even the irrational numbers are real numbers. So this works for square roots. This works for pi and e and any other irrational number as well. So this is going to work for all of the numbers that we're used to dealing with on a daily basis on algebra. Okay, so the first property that we're going to look at is called the identity property. You're going to like these because they're actually pretty simple. The identity property of multiplication is a very simple property, and that is multiplication. There we go. The identity property is that for every real number a, if I multiply a times 1, it's going to equal a, which also equals 1 times a. Okay, so it doesn't matter how I multiply 1. If I multiply 1 by a number, I just get the same number. Simple, huh? But it does need to be identified as one of the properties that we're going to be dealing with. We've dealt with this actually quite a bit already. Anytime you've seen a number that was the same as 1, and you're multiplying it by another number, you usually just ignore that number because you know that it's going to end up being the same thing even if we don't do that actual step of multiplying by 1. There's also another property we're going to look at, equally as simple, the multiplication property of 0. And that is that for every real number a, if we multiply by 0, a times 0 equals 0. Another one that you're familiar with and that is very, very simple to apply. And again, we can multiply the 0 first or the 0 at the end. It doesn't matter because as long as we're multiplied by 0, our answer is 0. So the example in the book is that 9 times 0 equals 0. Any number times 0 equals 0. And then lastly, the inverse property of multiplication. This one, maybe you're familiar with. This one might be a little bit new to you. So the inverse property of multiplication states that anytime we multiply a number by its multiplicative inverse, okay, it's inverse. And you know what an inverse is because when you divide, you always invert a fraction and multiply. When you invert that fraction and multiply it, you're finding the inverse of that fraction. You're just flipping a number upside down. So for every real number a, and this has to be where a does not equal. I'm going to show this with a funny symbol because I don't have the unequal symbol. But I'm going to say where a is not equal to 0. You just draw in your notes the equal sign with the slash through it. This is true. A times 1 divided by a equals 1. Or another way to say this is 1 divided by a times a equals 1. It doesn't matter which direction you go, which one you multiply first. And the example is, and this will make more sense when you see the example, 3 times 1/3 equals 1. And you've known this too for a long time. It's just maybe you never called it the inverse property of multiplication. But this is something that's pretty simple to work with. So now we've talked about some properties of multiplication. Let's talk about some rules for multiplication. There are 2 rules that you're going to need to keep in mind. And actually, it's really just one rule applied 2 different ways. And that is rules for multiplying signed numbers. And that just means numbers that have a negative sign or a positive sign. But remember, we don't actually write a positive sign usually. We just sort of leave the number alone. But we do sometimes put a negative sign in front of a number to signify that it's the opposite of the positive version of that number. So here's how we deal with multiplying sign numbers. Again, this should be review and very familiar to you. The product of 2 numbers with the same sign, so this could be 2 positive or 2 negative numbers. The product of 2 numbers with the same sign is always a positive number, okay? So even if we're multiplying 2 negatives, we're going to get a positive. That's different from when we added signed numbers, because remember, if we added 2 numbers that were negative, we would keep the sign, we keep the negative sign. In this case, if you multiply 2 numbers that have the same sign, it's always positive, whether they're negative or positive, okay? The product of 2 numbers with opposite signs is a negative number. Doesn't matter if the opposite sign is on the first number or the second number. When you multiply 2 numbers with opposite signs, you're always going to get a negative number. Make sure you take a look at the examples underneath each of those rules on page number 57. And we're going to look at the official example number 1, as we work a few practice problems here. So what if you have the problem 4 times -8, 4 times the opposite of 8? Well, if I look at those 2 numbers, they have different signs, and the product of 2 numbers with different signs is always a negative number. So I'm just going to multiply. 4 times 8 is 32, but it's going to be -32 because they have opposite signs. Easy peasy. Let's take a look at another one. -6 times -0.7. Okay, so we're mixing in some rational numbers here. 0.7 is not a whole number or counting number integer. So does it work the same way? Well, yep, it works the exact same way. So if I do 6 times 0.7, my answer is going to be 4.2. So it's almost 42, but I have to move the decimal place 1 to the left. So I'm just going to solve that part like I normally do. But what do I do with the sign? Well, both of these values have the same sign. They're both the opposite. So the opposite of 6, the opposite of 0.7. Because they have the same sign, then my response must be a positive number. All right, what if we raise a number to a power? Let's take a look at example 2. Okay, and we're going to take a look at example 2a. This is going to be -3rd. I'm going to put that in parentheses to the 4th power. Now let's think about what that means. -3 to the 4th power is -3 times -3 times -3 times -3. Because I can just do a couple of multiplications here. 3 times 3 is 9. And if I take because they have the same sign, it's going to be a positive 9. So if I just do this in steps, 9 times, so I would have 9 for my first answer because it has to be positive because those both had the same sign. I'm going to multiply that times a -3 times -3 is going to give me, well, it has to be a negative number because they have opposite signs. So that's going to be -27. And then I have -27 times my last 3, -3, and they have the same sign again. So -27 times -3, that's going to give me positive 81 in the end. And my answer there is going to be 81. Now, here's a little side rule that you can kind of keep in mind. When you're dealing with negative values raised to a power if they're raised to an even power, 4 in this case, they're always going to end up being positive. Even if you have a negative base for your exponent, the number is always going to end up being positive because you're always going to multiply an even number of times, and that's going to wipe out that negative sign. You'll always end by multiplying two negatives together to get a positive. If the exponent is odd and you're raising a negative base to that exponent, then you're always going to end with a negative number because you'll end up multiplying a positive by a negative for your last multiplication. All right, let's take a look at another example of this. Let's take a look at B. In part B, we have -3. Notice -3 is in parentheses, so I'm raising the entire -3 value to the third. Well, that's going to be -3 times -3 times -3. That's going to start off the exact same way. So I'm going to have 9 times -3 is going to be where I finish this one. Well, I have a positive, because I start with -3 times -3 is 9. They have the same sign. Now I have this positive 9 times -3. That's going to give me 27, but I have a positive times a negative. They have opposite signs, so it has to be -27. When you raise to an odd exponent, when you have a negative base raised to an odd exponent, you're always going to end with a negative number. Hey, let's look at letter C. I think this one's going to be a little bit surprising to you, okay? And this is one thing you're going to absolutely have to keep in mind when you're working these kinds of problems. What if we have one written a slightly different way? -3 to the fourth. Now notice I didn't put my -3 in parentheses. This means something specific in algebra, okay? That means that my negative is actually applied to the value 3 to the fourth instead of my negative being applied just to the 3 that's being raised to the fourth. So that means that I have to do 3 to the fourth first and then apply my negative. So this is going to be 3 times 3 times 3 times 3, okay, 3 to the fourth. And then it's like I have that and then a negative on the outside of the parentheses. So whatever the value of 3 to the fourth is, it's going to change its sign at the end and become negative. So in this case, 3 to the fourth we know is already 81. This is going to be -81. All right. So you have to pay attention to whether the base of your exponent is in parentheses. And you have to make sure that you are raising to that power whatever is the base of the exponent. If it's negative and then 3 to the fourth without the -3 being in parentheses, you have to do 3 to the fourth first and then apply the negative at the very end. If it's -3 in parentheses to the fourth, then you're actually multiplying -3 together by itself 4 times. And that's how you do exponents. Next, we're going to talk about dividing numbers.